On a few protected islands around New Zealand, and in carefully guarded sanctuaries, there lives an animal that seems at first glance almost ordinary. It has scales, a long tail, clawed feet, and a low body that moves close to the ground. Many people would casually call it a lizard and move on. But the tuatara is not a lizard. It is the last living representative of a reptile order that once spread across the world when dinosaurs were becoming dominant. Its story is not simply about age. It is about isolation, survival, extinction, and how one quiet animal can preserve clues from a vanished chapter of reptile evolution. The name Tuatara comes from the Maori language and is often translated as meaning peaks on the back. That name points to one of the animal's most visible features, the spiny crest running along its neck and back, especially pronounced in males. Adults are usually greenish-brown or gray, colors that help them blend into rocks, soil, and vegetation. A large tuatara can reach around 80 centimeters from head to tail and weigh more than a kilogram. Those numbers may not sound dramatic, but the real importance of the tuatara is not in its size. It is in what it represents, a living endpoint of a lineage almost completely erased from the modern world. To understand why the tuatara is special, we need to look beyond appearances. Lizards and snakes belong to a group called squamates. Tuatara belong to a different order called Rhynchocephalia. Today that order has only one living species, Sphenodon punctatus. But in the distant past, rhynchocephalians were not rare curiosities. They first appeared in the fossil record during the Middle Triassic, roughly 244 to 241 million years ago. Over time, they spread widely and became a successful group of small reptiles. During the Jurassic period, when dinosaurs dominated many larger ecological roles, rhynchocephalians were among the most important small reptile groups on Earth. That ancient success makes their later disappearance even more striking. Rhynchocephalians declined through the Cretaceous period, and their fossil record outside New Zealand eventually ends after the Paleocene. The reasons were likely complex. Changing climates, shifting habitats, competition with other reptiles, and broader ecological disruptions may all have played roles. What matters is that, almost everywhere, the group vanished. Only in New Zealand did one branch survive into the present. The tuatara is therefore not just an unusual local animal. It is a survivor from a once diverse reptile world, preserved by geography and protected, in part, by the isolation of New Zealand's ecosystems. Calling the tuatara a living fossil is common, but the phrase can be misleading. It suggests an animal frozen in time, unchanged for hundreds of millions of years. Scientists today are careful with that idea. The tuatara does preserve some body features that resemble those of ancient relatives, and that makes it extremely valuable for studying reptile evolution. But no living species is truly unchanged. Tuatara have continued to evolve, adapt, and respond to their environment. They are not museum pieces that somehow stayed alive. They are modern animals with ancient ancestry, and that distinction matters because it respects both their history and their ongoing biology. One of the most unusual things about the tuatara is its skull and teeth. Unlike many reptiles, it has a second row of upper teeth on the roof of the mouth. When the jaws close, the lower teeth fit between the two upper rows, creating a slicing action. These teeth are not replaced in the same way many lizard teeth are. Over time, they can wear down, especially in older individuals. The skull also has a completely fused temporal bar at the back, a feature that differs from typical lizard skulls. These anatomical details may sound technical, but they are exactly why scientists value the tuatara. Its body preserves structural information that helps compare living reptiles with ancient fossil forms. The tuatara's body includes other features that separate it from the lizards it resembles. It has gastralia, sometimes described as belly ribs, which are bones embedded in the body wall rather than attached to the spine like normal ribs. It also has small proatlas bones in the neck, another unusual skeletal trait. Even its hearing is distinctive. Tuatara can hear, but they have no external ear opening. To a casual observer, These details are invisible, but together they reveal that the Tuatara is built according to a different evolutionary blueprint. It is similar enough to a lizard to fool the eye, yet different enough to occupy its own deep branch of the reptile family tree. For most of their modern history, Tuatara survived in a place that had very few native land mammals. New Zealand's ecosystems evolved in isolation, with birds, reptiles, and invertebrates filling many ecological roles. That isolation was both a shield and a vulnerability. It protected Tuatara from many mammalian predators for a long time, but when humans arrived and introduced new animals, the balance changed quickly. Rats, especially the Polynesian rat, became a serious threat. Eggs and young Tuatara were vulnerable, and populations suffered. Habitat loss added more pressure. A species that had survived deep time suddenly faced dangers that arrived in only a few centuries. By the modern era, Tuatara had disappeared from mainland New Zealand. The remaining wild populations were confined to offshore islands, places where introduced predators could be controlled or were absent. That retreat shows how fragile even an ancient lineage can become. Survival across millions of years does not guarantee survival through rapid ecological change. A species can endure ice ages, shifting continents, and changing climates, then be pushed toward extinction by a small introduced predator in a nesting area. The Tuatara's story is therefore not only prehistoric. It is intensely modern, because it shows how human movement and habitat change can rewrite the fate of species almost overnight. Legal protection for the Tuatara began early compared with many other conservation efforts. It has been protected by law since 1895, a recognition that this animal was both rare and important. But protection on paper is only the beginning. Conservation requires predator control, habitat management, careful monitoring, and sometimes translocation to safer areas. Because Tuatara reproduce slowly and depend on secure nesting sites, rebuilding populations takes patience. Their future cannot be secured by a single dramatic rescue. It depends on long-term commitment, repeated checks, and the slow work of making places safe enough for eggs to hatch and young animals to survive. One important milestone came with the return of Tuatara to a protected mainland sanctuary. In 2005, Tuatara were released into Karori Wildlife Sanctuary, now known as Zealandia, in Wellington. The site is heavily fenced and carefully monitored to keep out predators. This was not simply a symbolic release. It was an attempt to restore a species to part of its former range under conditions where it could genuinely survive. Then, in late 2008, during routine maintenance, a Tuatara nest was found. A hatchling appeared the following autumn. This was believed to be the first successful wild breeding of Tuatara on New Zealand's North Island in more than 200 years. That hatchling mattered because it proved more than survival. It showed reproduction, and reproduction is the real test of conservation. An animal can be moved, displayed, and protected as an individual, but a population only has a future if new generations are born. For Tuatara, every successful nest carries extra weight because the species represents an entire order of reptiles. If Tuatara disappear, Rhynchocephalia disappears from the living world with them. Their recovery is therefore not just about saving one strange reptile. It is about keeping one of evolution's oldest surviving branches alive, not as a relic, but as a functioning part of New Zealand's natural heritage. The Tuatara teaches a quiet but powerful lesson. Evolution is not a straight line of progress from primitive to advanced. It is a branching process, full of experiments, expansions, collapses, and survivors. The Tuatara's relatives once flourished across the planet, then faded until only one species remained. Today, that species depends on human restraint, scientific care, and protected habitat. It looks modest, almost easy to overlook, but it carries a history older than many of the animals we usually call ancient. To protect the Tuatara is to protect a living connection to a lost reptile world, and a reminder that survival is never guaranteed. If you found this helpful, please like this video and subscribe for more explainers.